Hey guys, welcome to another video today. Uh, so the webinar just finished. I let them go early because I told them to watch the recorded one today because today's discussion is a little different. We're not doing a PowerPoint like we normally do. We're gonna read an article on National Geographic on the ozone layer depletion. So if you've been on ourbeautifulearth.org, you've probably read the article on ozone depletion under the current global concerns. But we decided to do a seminar on it if you wanted a more in-depth understanding. And we did the discussion if anyone had any questions on the topic or wanted to know how they could help. We're going to cover that in this on this seminar today too. But we're trying out something different. It's from the National Geographic, so all credit to them. But first, we're going to watch this video. It's an explanation on the ozone layer depletion explained. So, human activity has damaged this protective layer of the stratosphere, and while the ozone layer health has improved, there's still much to be done. To be honest, COVID has temporarily improved the ozone layer problem because there's less pollutants and companies industrializing, but that's going to change once it's all over. But still, it's improving. It's on a continuous cycle. But let's watch this video first.
Kilometers above Earth's surface, a gas called ozone surrounds the planet. The ozone layer acts as a barrier between Earth and ultraviolet radiation from the sun. However, pollution has caused the ozone layer to thin, exposing life on Earth to dangerous radiation. Earth's atmosphere is made up of 6 layers. The second layer, called the stratosphere, contains the ozone layer. The ozone layer is made up of a highly reactive molecule called ozone, which contains 3 oxygen atoms. Ozone is a trace gas in the atmosphere. There are only about 3 molecules for every 10 million molecules of air. But it does a very important job. The ozone layer acts as Earth's sunscreen, absorbing about 98% of damaging ultraviolet or UV light. But the ozone layer has gotten thinner. Chemicals called chlorofluorocarbons, or CFCs, are the primary culprits in ozone layer breakdown. A CFC is a molecule that contains the elements carbon, chlorine, and fluorine. CFCs are mostly found in refrigerants, aerosols, and plastic products. When CFCs are exposed to ultraviolet rays in the atmosphere, they break down into substances that include chlorine. The chlorine reacts with the oxygen atoms in ozone and rips apart the ozone molecule. Areas of damage in the ozone layer are often called ozone holes, but that name is misleading. Ozone layer damage is more like a thin patch, with the thinnest areas near the poles. The ozone layer above the Antarctic, in particular, has been impacted by pollution since the mid-1980s. There, the region's low temperatures speed up the conversion of CFCs to ozone-damaging chlorine. About 90% of CFCs currently in the atmosphere were emitted by industrialized countries in the Northern Hemisphere. In 1989, the Montreal Protocol banned the production of ozone-depleting substances. Since then, the amount of chlorine and other ozone-depleting elements in the atmosphere have been falling. Scientists estimate that chlorine levels will return to their natural state in about 50 years. By then, the Antarctic ozone hole will shrink to smaller than 8 million square miles.
So, if you didn't understand the technicality behind that video, they did explain it in pretty simple terms. But the big idea is ozone layer is being damaged because of CFCs, which are chlorofluorocarbons, which are in many of our everyday substances such as refrigerators, aerosols, and many more that we might not even know of. But the Montreal regulation has definitely significantly reduced this issue, but some companies still get away with making products that have CFCs in them. So even your fridge, if you could that's a daily household necessity. So I can't say you shouldn't stop using it. But for aerosols and stuff, you might want to find a more natural alternative, because who knows, the one you might be using may have CFCs in them. And by 2065, it's predicted to almost diminish, but that's if we keep going at this rate and no other new bills are passed to veto the Montreal regulation. So let's read this article. I read it before this seminar just so I could get a quick overview of it. If you want to read it, I'll put the link in the description of the video. But yeah, let's start. Over the past 30 years, humans have made progress in stopping damage to the ozone layer by curbing the use of certain chemicals. But more remains to be done to protect and restore the atmospheric shield that sits in the stratosphere about 9 to 18 miles, 15 to 30 kilometers above the Earth's surface. Atmospheric ozone absorbs ultraviolet or UV radiation from the sun, particularly harmful UVB type rays. Exposure to UVB radiation is linked with increased risk of skin cancer and cataracts. So skin cancer, many of you may not have had, but you probably know of when you go to the beach or something, and which is why you wear sunscreen, to protect yourself from getting skin cancers and other skin-related diseases. And cataracts, this is an eye problem. It occurs usually in older age, but UVB radiation can contribute to this. As well, the most important part is it does impact the damage done to plants and marine ecosystems if there's more UVB radiation. So remember again, the ozone layer protects us from UVB radiation and other living species. And if that hole is opened like it is currently, more of that radiation comes into our planets and impacts us and other species. Atmospheric ozone is sometimes labeled as the good ozone because it's protective ozone and should be confused with tropospheric or ground level bad ozone, which is like the reason of why we have so many respiratory diseases. So what is ozone again? It is a highly reactive gas whose molecules are comprised of 3 oxygen atoms. Remember, it's in the video. Its concentration in the atmosphere naturally fluctuates depending on seasons and latitudes, but it generally was stable when global measurements began in 1957. So now let's go to ozone threats and the hole. So we know from the video of the contribution CFCs had to this problem, and the groundbreaking research was done fairly recently. It was done in the 1970s and 1980s, which revealed this problem, and now it's being helping to be fixed. So what is the ozone layer status today? Recognition of the harmful effects of CFCs and other depleting substances led to the Montreal Protocol on Substances that Deplete the Ozone Layer in 1987. This was a landmark agreement to phase out those substances that has been ratified by all 197 UN United Nations member countries. Without the pact, the US would have seen an additional 280 million cases of skin cancer, 1.5 million skin cancer deaths, and 45 million cataracts. And the world would be at least 25% hotter. So we can see how all of these problems interconnect with each other. You will see often that a lot of these connect to global warming and climate change, like the ozone layer does. Some of them even contribute to deforestation, wildfires, etc. If you want to learn more about these connections, or if you're confused about them, you can look at ourbbeautifulearth.org, or you can contact me. So more than 30 years after the Montreal Protocol, NASA scientists documented the first direct proof that Antarctic ozone is recovering because of the CFC phase down. And this is why the Montreal Protocol was so important, because it put a regulation. It said stop using all this ozone to countries. It said limit it by any amount you can. And this is why our ozone layer problem is getting less and less major, but it still exists. So if you do have aerosols or CFCs being used in your house, try to reduce or not use them at all in some way. Monitoring the ozone layer continues, and it's finding that the recovery may not be as straightforward as hoped. A study in the early 2018 found that ozone in the lower stratosphere unexpectedly and inexplicably has dropped since 1998, with another pointed to possible ongoing violations of the Montreal Pact. The world is not yet in the clear when it comes to harmful gases from coolants. Some hydrochlorofluorocarbons, which is another type of harmful molecule. If you want to learn more about this, you can always Google it. And transitional substitutes that are less damaging but still harmful to ozone are still in use. Remember, the Montreal Protocol only put a limit and ban on the use of CFCs, not HCFCs. And developing countries need funding from the Montreal Protocol's multilateral fund to eliminate the most widely used of these, the refrigerant R22. The refrigerant. How many of us have a fridge in our house? Every one of us needs it to store perishables. So this is a problem that's contributing the most to the ozone layer depletion. Though hydrochlorofluorocarbons represent a small fraction of emissions compared with carbon dioxide and other greenhouse gases, the planet warming effect prompted an additional to the Montreal Protocol, which was the Kigali Amendment in 2016. The amendment, which came into force in January 2019, aims to slash the use of HFCs by more than 80% over the next 3 decades. This was in 2016, so 3 decades from then will be the 2046. So this thing is still in action, and we're hoping to see a big change in the ozone layer problem with this new regulation also. In the meantime, companies and scientists are working on climate-friendly alternatives, including new coolants and technologies that reduce or eliminate dependence on chemicals. So you might be wondering, why does this matter? Like I said before, it all comes down to our health and the health of other living species. If it didn't impact us, we probably wouldn't be so worried and we wouldn't be working on it. But there are always ways to help problems such as these. So, like I said, I've mentioned this many times. I know that you're probably tired of it by now, but see if you have any CFCs or HCFCs or any other ozone depleting products in your house, and see what you can do to cut down on it. See if you can find maybe a more ozone-friendly refrigerator as an alternative to the one you've had for a while now. This is just an example, but there's many things we can do. As I said before, today's webinar, if you were at the meeting, you are not seeing this live because I cut it off early because this was a new way of learning information and deciding how we can help the environment in what ways. So, and it's almost the new year, so that's another reason why I had a shorter webinar discussion. And if you still haven't come to any webinars, webinar discussions, please do, because first of all, they're not recorded, so you can't see it even if you didn't come to them. And second of all, they have really great insight. We're gonna have another guest speaker next week from a member of the UN coming, but we're not allowed to record because of privacy and other infringement issues. So that's it for today, and thank you all for watching.